Alrighty, hey gang, welcome back. So today I want to show you my techniques for building doors and hardware for rocket stoves, masonry heaters, things like that. You know, I've been doing this for a while now, and this is always the biggest challenge is how to build these for yourself, how to share them with other people, how to get one done for a job, for a build. Always a problem. Usually we were doing steel and welding, and it's not that hard once you get into it, but it's a big barrier to get into for a lot of folks, and it is a lot of work, and it's a lot of grinding for me anyways, because I'm bad at it and a mess and noisy and stuff. So anyways, here's what I have come up with to share with you guys for ways that we can move forward with this and get these into more people's hands without special skills or real expensive parts. So here's my doors. I've got a couple different techniques going here. I'm going to share with you a couple of different ideas and ways that you can possibly do this. These are dead simple. Really, all they are is my favorite material, ceramic fiberboard, 1 inch thick. And, you know, the board really is the door. The metal is just the skin. So I know that's hard to wrap your head around at first when you're looking at it, and when you're thinking about it, you think aluminum door with insulation on it. But really, you can build this without the metal on there, and it will work just fine. So the board is durable and rigid enough to hold its own shape. You know, one of the real advantages here is this whole assembly is really light, so the mounting to the masonry frame and everything else becomes a lot easier. You're not going to have decades of heavy steel, you know, a steel door pulling on that for decades. Anyways, that's enough rambling about all that. Let's just take a look at what I've done here, and I'll show you a couple ideas and techniques. I'm on my little cart, and it's got squeaky wheels. Sorry about that. So here we go, aluminum door. I'll talk about the door first, and then we'll get into some of the hardware choices I've made here. So the door itself is, as I said, it's just a piece of ceramic fiberboard here. There's not much of it left, right? Because I had to cut some out for the window, and then this little bridge piece actually just went away, but that doesn't matter. You got your primary air inlet there. So what I've done here is I take this piece of ceramic fiberboard. Now there's a ceramic fiberboard face as well behind this. So the door flange, as I'll call it here, the aluminum door flange, is mounted to steel angle iron that makes a frame around this opening. So whenever I make an opening for an oven door, firebox door, any of those things, take steel angle iron. The best way to get that I've found is salvaged bed frames. You guys all probably have one of those laying behind your barn if you got a barn. And just cut that into shapes. You don't need to weld it, although you can, and or you could bolt it together, but typically that's not necessary. Just you want one long enough to cover your span up top, and you have to cut out the sides so you can get the flange pointed down. But it has to go across the bricks there to carry it, whatever's on top, of course. And then the sides and the bottom is optional. Helps keep your shape square. And what that does is that gives you a point here to mount this flange to. So this is just a flat plate, and again, I'm choosing aluminum because it's what I have access to. It's easy to cut. It needs no special tools. It could certainly be steel. There's no reason you couldn't make this out of steel if you preferred that look, or if you were concerned about the material. So I just use self-tapping metal screws there. You got to pre-drill, of course, and get it in there. And same thing on that side to mount it. That gives you a great place to mount your hinges. So that's how you mount the flange. You get your angle iron frame around your openings. You use a piece of that frame for the header to carry your bricks across the top. And then you simply mount your flange to that frame. Now what I've done here, I've got the opening has a little threshold here. There's about a 2-inch drop back there that helps keep the ashes and dirt inside the firebox, and it helps me push the incoming primary air up over the fuel as well. So back to the door. The door itself, just ceramic fiberboard as an inner piece, and then in this case I've got an aluminum skin. Now if you want to do a window, this is ceramic glass. It's made by a company called Shot. This product is called Robax. I found these little 6x6 squares on eBay for a real reasonable price. That is simply captured between that ceramic fiberboard and the aluminum face. You could let it into the ceramic fiberboard a little bit if you wanted to take the time to whittle away at that. And then all I've done is I've just riveted, and you could use fasteners and big fender washers. And underneath this black stuff here, there is some smaller washers that are pulling that ceramic fiberboard to the aluminum. So that's how the ceramic fiberboard is simply fastened to the aluminum with fasteners of your choice, could be rivets. And then to create a seal, I just simply, you know, it will seal fairly well, just the board itself. But if you want a better seal, you can get some fiberglass rope, and you can just simply pin it to the ceramic fiberboard using small finish nails or pins or tacks. You might carve into the board a little bit and let it in some areas where you need it to be deeper, back there against the hinges. And that makes a great seal. So that's the body of the door. Now in this one, to make it look nice, I simply dressed it up with, this is what's called road case hardware for musical or equipment road cases. You can find it on Amazon. I'll try and see if I can get a link for you. It's just aluminum. I think it's 3/4 inch angle trim, and then they make these steel corners for the same use for road cases. So these are steel corners for road case hardware, and again, I just riveted them on. You could use screws if you wanted to, but in that way you can create a door, no welding, just simple cutting with woodworking tools that looks fairly finished. So works for me anyways, and like I said, it's nice and light. It doesn't feel like it's working on the body of the stove at all. There's no motion there. And it's easy to work with, to screw hinges into. You know, it was just a simple matter of I riveted the hinges onto the door frame because I had my rivet machine there, but that's what I did there. So the closure, again, this is road case hardware. These things are really inexpensive. This is what they call a butterfly latch, I believe. I think I got that right. And it usually just has this little handle here. Now what I did is I riveted, I went and got a spring at the hardware store and riveted that on there so it'd be cooler. But you know, this whole face actually runs very cool to the touch, even when it's running, because of all that insulation. So I don't know that this was necessary. It actually came off a different stove. So as you can see, the way it works, you just put a little catch there, doohickey. Mine's of varying lengths as I was trying to dial in my seal. And then the little grabber there grabs, and then when you turn it, it sucks it in. And it's a nice clean little latch. You can fold it out of the way. Inexpensive to do. These parts all together in that latch, you know, $30 or so. It's not free, but you know, a lot of those masonry doors are real expensive. So anyways, there's the door, a basic door. Now there's another real easy way you can achieve this without even going this far. And that is, as you can see, this is a ceramic fiberboard, you know, opening behind the door flange. If you were to simply cut a plug, in other words, if you had taken that first sheet of ceramic fiberboard and just cut this piece out and kept this piece that fit in there perfectly. I've got a little one here that doesn't fit perfectly, but we can imagine. It went in there flush like that. You could simply put another piece of ceramic fiberboard or even your metal skin, bolt that to that, and let that metal skin come out here and create the seal. So that's what I would call a plug door. You would just have this thing as a little plug. It would pop in there, and then there'd be a skin out over the top. You probably wouldn't even need the skin, but you could hinge it that way or make it look nice. So that's another really simple way to make a door. And another way to do a simple door, in this case, is my oven door. So this was pretty prototypical. It's pretty messy. I'm not 100% done with my latching and all that, but this was a really easy solution. All this is, again, ceramic fiberboard. In this case, it's scraps. I got a couple of them. I used fender washers and some screws, and just to a piece of aluminum. I found this on, this is an old trowel handle or something. And then all I did for latching was I just drilled into the bricks, and I used these little pins that I made from an old barbecue rack or something to go in there. And you can leave different lengths on them and, you know, get kind of a, well, that's not quite right, but you can tension them in a way if you like. Now this door is just seated on a simple ceramic fiberboard seal. And again, there's angle iron behind that, a steel frame that creates the opening. And then I just put the ceramic fiberboard on there, and then the door itself is backed with ceramic fiberboard. Now I'm not sure that this board-to-board seal is better than the board-to-metal. This was just a test. But it's real easy, and one of the things I really like about this as opposed to a hinge door is I'm limited in space here for the opening, so this gives me a nice, it maximizes my oven opening size. In other words, a hinge door, you always lose a few inches. So it's just that easy. I don't, that's usually like a 10-hour brisket cooking roaster thing, so if you were in and out of there all the time, that probably wouldn't be what you wanted to do, but that works for me. Okay, so there's a third type of door. And let's talk about hardware and bypasses real quick. So I took the top off of this guy just now. It's warming up a little outside. It's almost, it's 44. It's been down and below freezing for the last few weeks. So I got the top off, and the reason I did this, I wanted to show you the bypass. We're not going to be able to see it real well, but I'm going to be able to tell you about what I did and show you some of the function of it. So the bypass in this one is, I'm trying to shine a light in there, is held up. There's a tunnel there created. I've got a couple of scraps of brick and some ceramic fiberboard, and then just this brick facade, as you can see over the top. Those are real bricks, and then these were just little veneers I made, little skins that make it look like there's continuing brick. There's actually a tunnel underneath here, and then this area here is an aluminum exhaust flange, and I just bedded the. It's down about 1/4 of an inch, maybe 1/2 an inch, the aluminum flange, just a flat piece of aluminum with a 6-inch hole in it. This just mates to that 6-inch hole, and then I just used mortar to seal it. Now, bypass right here. This is so simple, you guys. People agonize over these so much. This is a coat hanger stuck through a piece of ceramic fiberboard. And then above the ceramic fiberboard, I had pre-bent the coat hanger with a little bend, and then it protrudes just right through the middle. I pre-drilled the ceramic fiberboard. This goes through it, and then I just put a little hook on the bottom so it can't go in or out. In that way, I've got a piece of ceramic fiberboard suspended like this in the chimney space, as it were, opening and closing this gap. Now, if I didn't have this table here, I think I would have preferred to do it this way. I would have had my lever here, and I would have just, because that way the ceramic fiberboard would have been resting on this surface, and it would be flat, and it could face against there and get a nice seal. As it is, it's facing against materials this way, and it has a pretty good seal. I don't think I'll be able to show you like this, but I was shining my light in there earlier and check it out, and it's sealed pretty well. So it's a little crusty because it's got sand going in it, but it works pretty simply just by dropping it down like that. And can you see? I don't think so. Anyway, I can see it, and that opens up this passageway, and simply pulling it back up, and its friction from those little sandy bits is enough to hold it. Closes it fairly well. Now, it's a nice flat piece of ceramic fiberboard. I did make sure when I finished that off, I used mortar to make a nice facing to it. So it's sealed pretty well. You can monitor that. I can monitor that by watching the oven temps when I manipulate that, and they change instantly and dramatically. So that's my method for creating simple baffles. Again, another thing people agonize over, ceramic fiberboard makes it really easy. Now, for other folks who are building my tiny cook stove, I should just point out that at the bottom of this downdraft chamber, which carries the flue gases down to the oven and to the bench, there is on this side, I'm going to grab my light. There is on this side, and you won't be able to see it because it's just going to be all black, but you can see that little board down there. Now that is a baffle that can close off the bench or open the bench. The bench will still get somewhat warm from the other entrance, which is over in the chimney area, but this would shortcut the oven, so it would, in a sense, would cool off the oven as much as warm the bench more quickly. And the reason I'm showing you this is because in my stove, I haven't installed it yet, But this would be a place where if you want that functionality to be manipulatable on a regular basis, you would put a what should we call it? Actuator. Anyways, coat hanger, something rigid, a piece of steel rod, something like that. And you could put it here and come up through the mortar here. There's enough space between the glass top and the mortar. And you could use it, put that here, and then put a kickstand on it and hold it up, push it down to close. You could also put one, if you had access, you could put it in the side of the stove over here, and you could push that board. There's actually space for it to go that way into the other chamber. So anyways, just wanted to share that aspect of bypasses. And I think that's gonna wrap it up for this one. I wanted to get that info to you guys, you folks who have bought plans. This door information is something that just really requires me to describe it to you. I did give you some specs and measurements on and how you're gonna cut these parts and fasten them, but nothing like looking at it, right? So hopefully that answers your questions. I would be happy to help you if you get stuck or answer any more questions you have on these. Now, I've been running these for, geez, it's been at least 3 years now, I guess. This door exactly, actually, I took it off. It's been from one stove to another, and they hold up great. I'm very, very pleased. I actually prefer it over the steel doors I've built. So there's my hardware information for you guys, and hope it helps. All right, thanks a lot for watching. See you next time.